Okay, let's start part 2B of my introduction to database. We're going to start talking about normalization. Right, let's see what normalization is about. Okay, so normalization is the process of organizing the tables in the database to reduce data redundancy and prevent inconsistent data. Okay, so there are three normal forms we talk about. We talk about first normal form, second normal form, and third normal form. So later you will see that we will want to try to reduce reduce the redundant data, also reduce the amount of transitive dependencies that exist within our tables. Right. So let's look at the first one. Let's look at 1NF first normal form. Okay, for a table with first normal form, right, in all columns must be atomic. Okay, so atomic here in this case, right, it means that there cannot be any multi-value columns. So for example, your information in each column, right, cannot be broken down any further. Okay, so let's say like you have things like a phone number, right? You cannot have, like just now we said earlier in the earlier video, we cannot have a phone number 1, phone number 2 within the same column. We need to separate them out. All right. So let's look at example now. Okay, so it's assumed. So let's say for example, right, if this case, right, why is this table not in 1NF? Okay, so there's some assumptions you make about this data first. Every civics class has only one civics tutor. Every CCA has only one teacher in charge. Okay, but if you look at this here, right, at the first few columns 1, 2, 3, 4, 5, 6 are okay. It's the last column that comes in a little bit tricky, right? Because right now you have things like this one over here. If you look carefully, right, you have this student, he's in tennis club. Then there's also the name of the teacher there. Then the second student, Adrian, he's in choir. So there's also one teacher I see, and it's also in the student council. They belong. So there are actually 4 bits of information inside here. One, choir CCA, choir teacher IC, student council IC. Right, then you have the same thing as well, Adam, and then like choir and also chess club at the bottom here. So this is not 1NF. Okay, so how do we convert this to 1NF, right? Unfortunately for now, you realize that you need to expand, you need to create more tables, etc. Okay, so we need to split them up. So basically, we want to separate. The first thing you can try to separate is to separate the name of the CCA and the CCA teacher IC. So this is quite straightforward. If you just look at this example here, Adam, right, I can just create one column CCA name and a column CCA teacher IC. But if you have, let's say, like multiple entries like this, you have multiple CCAs, do you create a second CCA2 CCA2 column and then a CCA2 teacher IC? Okay, then if you do it that way, right, then students with only one CCA will not have any entries within the CCA2. Okay, so a better way to do this, right, is to just to duplicate, is to kind of duplicate the entry. We look at it on the next slide here. Okay, yeah, so next slide, this is what we're doing. Okay, we split CCA info to 2 single value columns, CCA name and CCA teacher IC. Right, but there are some students with multiple CCAs, right? We have to enter their names twice. So for example, Adrian here, metric number 2, right? Because there's 2 CCAs, we need to put his entry in twice. Okay, so now you can start to see there's actually some bit of redundancy here. There's repeated data here, right? And number 5 as well. So because she has 2 CCAs, we need to create one more row for her. Okay, so in this case here, right? Now it's atomic, alright? So that's fine. Because in each column, in each attribute, right, in each record, the entry for this attribute is atomic. Alright. So how do we form the primary key here? Okay, we can no longer just use the metric number as a primary key, because right now you can see that there are 2 number 2s and there are 2 number 5s here. Okay, so we need to use the metric number and the CCA. Alright, so this is a composite key here. So both the metric number and CCA together will tell us which entry we're talking about. Right. So for example, if we pull up metric number 1 and tennis, we can identify the student. Okay. In fact, if it's just 1, we can just identify with just the metric number. But if it's a student number 2 here, right, you see that if just calling by 2 alone, right, you cannot identify which CCA you're talking about. So we need to use the CCA name as well. Alright, so this is 1NF. 1NF is quite simple. Basically, look for cells with 2 entries, with two or more entries. Okay, just try to split them up. Alright, next you will have 2NF. Okay, 2NF, to go into second normal form, right, it must first of course be 1NF. Okay, next, every non-key attribute must be fully dependent on the entire primary key. This means no attribute can depend on part of the primary key only. So in this case, of course, we are talking about a composite key lah. Because if your primary key is only a single item, right, a single attribute, right, then of course you have to depend on it lah. Right. So let's see what we have here. So let's look at this column now. Okay, so we have, let's look at this line by line. Name, gender, civic class, civic tutor, and homeroom is dependent on the part of the primary key. Okay, so in this case here, right, my name of the student, gender, civic class, civic tutor, homeroom are all dependent on the metric number. Okay. Okay, but remember this table here, right? Our primary key is a composite key consisting of the metric number and the CCA name. Alright, then also the CCA teacher IC is dependent only on the CCA name. Okay, so it does not depend on, like, what this is saying is that the name of the CCA teacher does not depend on the metric number. Okay, you can't tell that, because if let's say you go by metric number, right, you cannot, let's say you pick up two, right, you cannot decide which teacher you are talking about, Adeline Wong or David Leong. Alright, so you need, but this one, the CCA teacher only depends on the CCA name alone. Okay, so once you have the CCA name, right, you don't need the metric number to identify the CCA teacher. And once you have the metric number, you don't need the CCA name to identify the student's name, gender, civics class, and civics student homeroom. Okay, so this one is a bit more complex to split. We need to start to create extra tables here. Okay, so to change this to 2NF, right, we're going to create 3 smaller tables like this. Okay, so this one is a bit more complex, but let's just try to follow along. Okay, so just now we said the name, gender, civics class, civics tutor, and homeroom depends only on the metric number. Okay, so we're going to create one new table called the student, right? So basically, if you look at this, name, gender, civics class, civics tutor, homeroom can all be determined by the metric number. Alright, then we have a student's CCA record. So we have various entries of the metric number. So for students with 2 CCAs, we assign we give them two rows here. Alright, then we have the name of CCA. Then we have one more table called CCA information, CCA info, name of CCA, and CCA teacher IC. Okay, so this one here, let's look at which are the primary keys. I think it should be quite obvious for us to guess. Alright, for us to find out. Okay, the primary key for the student is the metric number. The student CCA is the metric number is your primary key as well. Then your CCA info, the primary key is CCA name, right? So I think this is quite straightforward. Okay, metric number, CCA name will form a composite key. Okay, so again, okay, I made a mistake here. For student CCA, right, because you can't tell the entry apart just by the metric number itself. You need a CCA name. So in this case, right, your CCA name and metric number will form a composite key. Alright, so the composite key serves as the primary key here. Alright, and then, yep, that's it. Okay, next, let's go to 3NF. Okay, 3NF, it must satisfy 2 conditions. First, it must be in 2NF, and then it should not have transitive dependencies. Okay, so let's look at this student table here. Alright, so remember how we talk about transitive dependencies. So let's see the civics class. Okay, so for example, once we know the metric number, we can identify the civics class. So the civics class is functionally dependent on metric number. Knowing the civics class does not tell me the metric number. So there is no functional dependency of the metric number on the civics class. Right? From the civics class, I can tell the civics tutor and I can tell the homeroom. So civics tutor is functionally dependent on civics class. Homeroom is functionally dependent on civics class as well. Okay, so that means the civics tutor is transitively dependent on the metric number. The homeroom is also transitively dependent on the metric number via the civics class. Alright, so these are transitive dependencies that we need to remove. Okay, and how do we remove these transitive dependencies? Basically, if you're not sure, right, you create a new table. Alright, So in create new table, what should you do over here? We break down our student table a bit further. We go like this. All right. We break it down. We go this way. So we have one table for student. Student will contain 4 attributes: matrix number, name, gender, and civics class. And then I will create one more table called civics. Civics will contain the attributes of civics class, civics student, and homeroom. Okay, so then let's see which are our primary keys. I think these are quite straightforward. So, and you can see that here, right, there's an example of a foreign key as well. Okay, I'll go pause. So if you look carefully, right, in this case, the civics class is the primary key of civics table. Civics class also exists in the student table. So civics class is a foreign key in the student table because it's a primary key of the civics table. Okay, so if you see this, right, once, like, now you can kind of start to see how the information will flow. So for example, if I pick out the matrix number, once I pick up matrix number, then I know, oh, the name of student is Adam, gender is this, and the class is 18S12. And if I want to find out about his class, right, find out more about his class, right, then I will go into the civics table and look for 18S12, okay, which is the primary key of the civics table. Then I can pick out his civics tutor and so his homeroom. Okay, so after 3NF, right, this is what we will get in our table, what we get in our database. So right now our database has a total of 4 tables. 1, 2, 3, 4. That's perfectly normal lah. Right, so you have student table, civics table, student CCA, and CCA information. Right. So again, we have this over here. So this is how we represent the table. This is how we write the table descriptions. Okay, and then for the solid underline refer to the primary key. Okay, so for example, under student, right, under student table, right, the primary key is a matrix number, so we underline it. Then because civics class is a foreign key here because it's the primary key of your civics. Okay, civics table. So I will do a dash underline. In exams, usually for this, we will just write as a asterisk. That's easier to do than the dotted underline. Okay, then the civics table, civics class is the primary key. There are no other foreign keys there. Student CCA is the one that's a bit more unique. Both the matrix number and the CCA name are your primary keys. Okay, so in this case, we kind of like basically underline it like that. But in the exam condition, you can just basically draw a solid line. So if I see 2 solid lines here, right, basically both of them form a composite key. Okay, then of course CCA info, right, the primary key is CCA name underline. There's no other foreign keys, etc. Right. So this is the end of part 2B. You can attempt questions in C4 normalization, question 3 to question 9. Thank you.